Hello everybody, welcome to another interesting video. I'm Soldering is my name. Thank you very much for stopping by. In this video tutorial, again, we are going to be making a saltwater battery. I know I've kind of made a saltwater battery before. If you want to get that breakdown tutorial, just click down below, or click up below I should say. Anyways, in this video tutorial, we're going to make an upgraded version. Yes, an upgraded version. I'm going to be making a saltwater battery which can be able, if it will be able to power my soldering iron. So we're going to find out in this video. We're going to put up the parts. I'm going to list out the parts which I'll be using in this project. Do all to stay to the end, and let's go into the video, chat. Subscribe. Now, the component which you're going to be using in this project is very simple, and I'm going to be listing it out for you guys. Now, the first component which you're going to be using is actually the salt. Yeah, the salt is actually the basic component which is needed to be able to make the battery to work. Secondly, the second component which we're going to be using is actually the two metals, which are the zinc and the copper. These are the two electrodes which is going to be used in the battery making, in other words, the saltwater battery making. And yes, thirdly, the component which you're going to be using is actually the booster. Yeah, I actually explained that in the beginning. I'm going to be trying to power my soldering iron with this saltwater battery. So this booster module right here is going to help me boost some kind of voltage. If you want to check the review on how the booster actually works, check above. I actually made a different review for it, but anyway, this is the booster which you're going to be using in this project. Fourthly, the component which you're going to be using is actually the USB. Yeah, this USB is going to serve a particular role in this project, and you're going to see to that. Don't ask me questions, let's just move on. Now, talking about the cup. Now, the cup which you're going to be using is actually this mug cup, actually a glass cup. I actually found this cup and I found it suitable for this project, and this is the cup which is going to be inserted. We are going to be inserting our electrode and also pouring our water and our salt. So I found this cup and it's really nice. You can also use a glass cup, or you can use any rubber container. It's still going to work maybe, but in my case I chose this cup. Now, talking about the copper, where are we going to get copper from? Anyways, I found a copper from a wire, and I actually found it in my lab, and actually just found it as an old used electric wire. But this is the electric cable which you're going to be salvaging copper from. We're going to be removing the rubber on it as so we are going to be using this copper, and it's going to be serving as copper in this saltwater battery procedure. And also zinc is very simple. We are going to get it, and this is it. You just need to find these two electrodes. This is the most important thing, and this is the most important electrode which you need to get when you're making a saltwater battery. Now, there's also other utilities and other tools which I'm actually using in building the saltwater battery that I actually forgot to mention, which is the wire cutter. Yes, this wire cutter is going to serve a great role in maybe removing some rubber from the wires, and also some cutting of wire job. And also, we are also going to be using the super glue. Yeah, the super glue is going to play a very good job in placing the electrode side by side inside of the copper to keep it firm and keep it nice. Also, we are going to be using the soldering iron to solder some kind of wires and some kind of loose joint. Also, the lead is going to serve as the solder, and let's just go into the build. Now, firstly, the copper right here which you actually got is going to be placed side by side of the cup. The zinc is going to be placed on one side, and the copper is going to be placed on the other side. In this case, this copper is going to be placing right here, which I'm actually showing you guys. But we are not just going to be placing the copper just like that inside of the cup. We're going to be bending the copper a little bit to make it like a snake-like way. I don't really know how to explain it. Let's just do it. I'm going to show you the final result. This is how I want it to look like. I want it to look like this. I don't want it just to be straight. I want it to be like, you know, like this, to actually make the battery efficient or the cell efficient. I don't know, I just felt that making the copper a little bit bent is much better and will give the cell much efficiency. Now, in my last saltwater battery video, I actually made only 2 cells. Yes, because I just wanted to power only a LED. But in this video tutorial, we're going to be powering something much bigger, which is going to make us to make about 4 cells. So we are going to be using 4 cups, 4 copper electrode, and 4 zinc electrode, as you can see right here. This is the electrode and this is the zinc. Okay, now the first thing which we're going to be doing now is that we are going to be adding some salt into this glass cup. Now we're going to be adding the salt, then we're going to add the water, and we're going to repeat the process for the 4 cups of glass cup which we have right here. So I'm just going to put around half tablespoon inside of the glass cup, and we're going to repeat that for all the glass cup which we have right here. Sorry, this one doesn't have a label. I guess it's peeled off anyways.
Alright, so we are done filling it with the salt. As you can see right here, now we are just going to put in the water into the glass cup. But first up, before we put in the water into the glass cup, I actually mentioned that I actually formed this copper, which is actually right here. So we're going to place in the copper side by side. We're going to place the copper at the side of the cup like so. And we are going to place in the zinc, which I actually carved out also at the side of the cup at so we're going to bring it down a little bit, so it must be inside of the water. So let's just do that.
Alright, before we glue the electrodes to the cup, let's first of all connect the electrodes to the wires. I think there's a problem with this soldering iron right here. I forgot I should have made the cons on this review video, but the soldering iron is not really that hot and cannot really take high temperature. So if you're soldering a very thick wire, you're gonna have challenges with it. That is why I'm going to be changing it to a better solder. I think this one actually works best though. Now let's glue.
All right, you can see right here we are done with the connecting of the electrode, or connect the electrode for the four cups right here. As you can see, now what is remaining is just to fill in it with clean drinkable water. Maybe distilled water will be better, but anyways, clean drinkable water. If I connect these two cups in series, I will be expecting to have around 2 volts, and if I connect all the cups in series, I should have around 4 volts, which should be going directly into the boost model, which I talked about, and we'll be having boosting the voltage to around 5 volt. And let's see if it can really power our soldering iron jet. I hope it works, and if you want it to work, you need to subscribe to my channel.
Okay, I guess it's well dissolved, as you can see. Alright, we're having around 628 millivolt from a particular cell, which is nice. So if I connect two cells together, I'll be having around 1.2 volts, which is not what I expect. I was expecting to have like around 1 volt from a particular cell, so that when I connect two in series, I'm going to be having like 2 volts. So let's increase the salt and let's test it again. Okay, I guess it's well dissolved. Let's test it out. Still around 600 milliamps. Alright, I guess this is just the level. I guess maybe if I want to increase the voltage, I just have to increase the quantity of water, but the cup is already full, so we're going to go with the voltage, and let's just connect them in series and see our final voltage. Measuring the total output voltage, we have about... Wait a second, do you actually know how it actually works? No, you don't. You actually want to see the result, but you don't want to know how it works? Impossible. Let's go find out how it works. Now, the saltwater battery actually works in this way. Now, the saltwater solution is now actually what is actually generating the electricity. If the electrodes are not actually inside, if you just put your multimeter, if you just shove your multimeter into the saltwater sodium electrolyte, you're not going to get any voltage. So it's actually the electrode that's actually enabling the voltage to come up. Now, when you put a salt into a fresh water, it actually splits into two charged ions, which are positive sodium ions and negative chloride ions. These free floating ions is actually what allows electricity to flow into the liquid, thereby completing internal circuit. Now let's go into the electrode and how it works. Now, talking about the two electrodes that are being used in this saltwater battery experiment, which is the zinc and is the copper. One is actually reactive and the other is actually less reactive. Now the zinc is actually more reactive while the copper is actually less reactive.
Now, the highly reactive metal, the highly reactive electrode, which is actually the zinc, actually releases electrons when dissolved in the water, because the zinc is actually highly reactive. So when you dissolve it in the saltwater solution, the saltwater electrolyte, it actually releases electrons. These electrons, which is being released, actually flows through the external wire to your circuit. Now, you know that you're going to be connecting, let me say you connect a bulb to the external circuit. You know that you're going to be connecting a wire from the zinc and also from the copper. So these electrons, which is being released by the zinc, actually flows through the external wire to your circuits down to copper. Now, because copper is actually less reactive, it actually creates a free landing space and actually accepts a zinc electrode with open hands.
The electrode travels through the wires and reaches the copper electrode. Here, hydrogen ions in the water accept these electrons and form tiny hydrogen gas bubbles. By accepting these electrons, the reaction can continue and allow electric current to keep flowing through the circuit, and the process actually continues.
Now, to wrap the explanation of the salt water is actually the electrolyte, while the two metals you actually input into the water is actually the two electrodes. Now, one is actually high reactive and the other is actually less reactive. The highly reactive metal actually releases electrons, while the less reactive metal, which is the copper, actually receives these electrons through the wire, through the external wire from your loads to the copper, and the salt water solution actually completes the circuit and make the circuit to work continuously.
So we're actually having like 2.5 volt at the output.
Alright guys, this is the final setup. I was forced to create another cell because the voltage needs to be more than 3 volts to be able to be supported by this booster module. So I need to increase it to 3 volts. So I need to increase it and add another cell. So this is the cell which I added, and I connected it in series, I guess. So I'm going to be testing the output, then we're going to be testing it with the booster module, and we're going to boost the voltage, and let's see how it goes. The place is kind of a dark because there's no electricity right now. So let's test it out. Bring up my meter, measuring the output total voltage of about 3.2 volts. 3.2 volts, which is nice. Alright, so let's connect it to the booster. Alright, successfully connected the USB to the board and also to now the cell's battery. And I'm going to reduce the light, or I'm going to turn on the light. I don't know. I'm going to connect it as so. Alright, going to turn on the light. Alright, I don't think the booster is actually turning on though. Damn. Now here's the close. Now basically the saltwater battery, which actually made in the past, actually generated about 1.8 volts when I joined two cells together. But with this saltwater battery, I'm having about 1.2 volts when I join two cells together, and having about 600 milliamps from one particular cell, which is kind of lower on what I expect. But I'm thinking that maybe the coil, the copper is kind of low. And in the other video, my old video, which actually made the saltwater battery, actually use more copper, and I guess it actually increased the voltage. So that all contributes. With the low voltage, I'm not having enough voltage to actually feed into the booster. And you can see in the clip that the booster is not turning on. Yes, the booster needs about 3 volts to turn on. And when I connect the saltwater battery, connected all in series, I was having about 3.2 volts. Connecting that to the booster, we are having about 1.2 volts. Yes, the saltwater battery all dropped from 3.2 volts to 1.2 volts, which is really bad. And it cannot really turn on the booster because the booster needs some power to turn on, and with the voltage being dropped like that, it's not going to work and it's not possible. So only the way to fix this is that I'm going to make it a part 2 of it. Sorry guys, we are going to make it a part 2 of it. I'm going to use a bigger cup. I'm going to make the copper much bigger. I'm going to make more windings. I'm going to make the zinc much bigger, and these properties actually increase the voltage, which is outputted from the particular cell, and you can have enough voltage to feed into our booster. I don't know if it's going to be possible, but we are just going to be trying. I'm just going to do the experiment off camera, and if it's kind of possible, I'm going to make the video out, and if it's not still possible, I'm going to let you know. Anyways, I'm going to be letting you know on my Patreon, so you need to join my Patreon. First link in the description is going to lead you to my Patreon. So sorry the project was not a success, but I actually did something to cheer you up.
Well, since my project was not a success, I just decided to connect this LED to the output of my saltwater battery to just cheer me up a little bit, and also cheer my viewers up. And stay tuned to part 2, which I'll be upgrading this thing. Yay, it actually turns on. Too bad. Thanks for watching, and I'll see you around.